In this question, you're given that the quadratic equation ax square plus bx plus a is equal to 0 and x cube minus 2x square plus 2x minus 1 is equal to 0 have two roots in common. If that is so, what is a plus b? So this is a slightly different question where you have a quadratic and a cubic. So if you carefully see this cubic is a simple cubic equation because you can find one of its root by a very easy trial and error. So as you can see, x equal to 1 satisfies this equation. The sum of all the coefficients is equal to 0. Hence, x minus 1 is a factor of this cubic polynomial. So let us factorize this. So as you can see, 1 satisfies the cubic. The number 1 satisfies the cubic. Hence x minus 1 is a factor. So I can divide this by x minus 1. So I'll use the Horner synthetic process to divide with x minus 1. X minus 1 is a factor. So 1 minus 2, 2 minus 1. So 1, 1, 1s are minus 1, minus 1, 1, 1, 0. So the remainder is 0. Hence, the quotient is x square minus x plus 1. So the cubic can be written as x minus 1 times x square minus x plus 1. And this is a very famous quadratic. This is a quadratic whose roots are minus omega and minus omega square. So x is equal to 1 minus omega and minus omega square. So these are the three roots to this equation. Now we have all the three roots to this equation, and these two equations have two roots in common. So what might be the common roots? You have three options. 1 and minus omega can be common. 1 and minus omega square can be common. Minus omega square can be common. So in this, if we assume that the coefficients are real, so these two cases cannot happen. Because if 1 and minus omega are the common roots of these two equations, 1 and minus omega has to be the roots of this equation. So if that is so, the coefficients will not be real because omega is a complex root and complex roots cannot occur in isolation. They always occur in pairs. So if minus omega is the root of this equation, minus omega bar, which is minus omega square, should also be the root of this equation. So 1 cannot be the other root. So 1 and minus omega, 1 minus omega square cannot occur as roots of a quadratic with real coefficients. Hence, you have only one option where minus omega and minus omega square has to be the roots of this. Minus omega and minus omega square has to be the roots of this. That means this equation has to be a multiple of x square minus x plus 1 is equal to 0. So these two equations should have both the roots in common. Hence, if you take the ratios, a by 1 has to be equal to b by minus 1 has to be equal to a by 1. This implies a is equal to minus b, and this implies a plus b is equal to 0. So the answer a plus b will be equal to 0. Thank you.